I know you've all heard about blood types before, and you may even know what yours is. But some of you may not know what it means when you say, I'm A positive. Let's talk about blood type compatibility to make sure that you know how this works in real life. When I saw this image on a friend's Facebook page the other day, my first thought was, I hope they're kidding, because someone's gonna die. What you see there is a bag of A positive blood, going to the main blood types we generally talk about. O positive, O negative, A positive, A negative, B positive, B negative, and AB positive and AB negative. If you hook all these people up like that, someone is going to die. The question is, do you know who would be dying? Let's make sure you do. What does it mean when somebody says my blood type is A positive? Blood types in general are factors in our blood. They're important when we do transfusions. There are 36 different known factors in our blood that distinguish one blood type from another. But the two main ones we usually talk about are the ABO blood type system and the RH system. The RH system used to be called rhesus factor, but that term has fallen out of favor. A person's RH blood type is important during transfusions, but also during pregnancy, because a mother can develop antibodies against her baby's blood if she's Rh negative while the baby is Rh positive. But let's talk about the A positive notation. If somebody says they have an A positive blood type, that means that their red blood cells contain the glycoprotein A from the ABO system, and they do have the Rh factor on their red blood cells. If somebody says they have A negative blood, that means that their red blood cells also contain the glycoprotein A from the ABO system, and they do not have the Rh factor on their red blood cells. So to reiterate that, the positive negative part of this description does not refer to any part of the ABO system. If someone is B negative, it does not mean they don't have B. It means that they have B from the ABO system, but they don't have the Rh factor from the Rh system. As you know, everything in your body has a molecular basis. Blood types are based on molecules that reside on your red blood cells. Those are proteins, carbohydrates, glycoproteins, or glycolipids, depending on the blood group system. The image on the right shows some of the factors determining your blood type. Since some of the factors are exceedingly rare, we will only discuss the most important ones here. The image on the right shows a cut through the outer membrane of a red blood cell. You see the phospholipid membrane that surrounds your red blood cells, and if you look closely, you see the glycoprotein determining your ABO blood group membership on the left of the membrane. The Rh factor is based on a transmembrane protein that is depicted in the middle of the cell surface representation. To reiterate again, the A part of the A positive notation describes your membership in the ABO system, while the positive, negative, or plus minus part of the blood type notation describes the presence or the absence of the rhesus factors. Because those are independent factors, they are inherited separately. So having an A, B, AB, or O blood type is independent of the absence or the presence of the Rh factor. When someone says my blood type is A positive, it means that they have the A glycoprotein and the Rh transmembrane protein on the outside of their red blood cell. We'll start by talking about the A glycoprotein first, and I'll discuss the Rh factor later. But since molecules are scary looking, and since many things in biology are based on shapes anyway, we'll simplify the whole thing a little bit by visualizing the A glycoprotein as its little balls on a stick on the outside of red blood cells. It's a lot friendlier looking, and it works just the same for an explanation. Your red blood cells, as the name implies, are part of your blood. When you donate blood at the blood center, the first thing they do most of the time is to spin your blood to separate it into its component parts. The heavier parts, which are your red blood cells, settle on the bottom while the lighter parts float on top. The liquid on the top that contains the free-floating molecules is called plasma. Your plasma contains, among other things, the defensive army that is busy patrolling your body at all times to keep you alive. This defensive army is also what's causing the trouble with transfusions. Specifically, your plasma contains molecules called antibodies. These antibodies are shown on the right-hand side on the right-hand side of the slide. They are Y-shaped molecules that recognize stuff with the top part of the Y. This part's highly variable, and your body creates antibodies to every molecule known to man and probably a few as of yet unknown ones. Ideally, your body does not create any antibodies that target molecules that exist within your own body. If an antibody binds to something, it activates additional helpers that will destroy or otherwise deal with the thing that was bound. So ideally, your body would not build antibody against things that it needs, like your own red blood cells. When bodies accidentally produce antibodies against molecules that are part of their body, that's called an autoimmune disease. A disease caused by the body attacking itself. But like I said, that's not the norm. Antibodies recognize shapes, and the shapes that can be recognized by antibodies are called antigens. So your A glycoprotein on the type A blood cell can serve as an antigen because its shape can be recognized by an antibody of the right type. Ideally, the plasma of our little friend with the blood type A would not contain any antibodies against A. Instead, their plasma would contain antibody against the B antigen, with the A antigen being shown as a red ball on a stick in our illustration. I'm showing the B antibody as something recognizing a triangular shape. Of course, blood type A is not the only blood type there is. As part of the ABO blood type system, we have blood types A, B, AB, and O. I'm again representing blood type A as little round balls on a stick, and I'm showing blood type B as triangular cones. So a red blood cell from someone with blood type A will be sporting little balls on a stick, and red blood cells representing blood type B will be carrying little cones. Blood type AB will be represented by carrying both the balls and the cones on the red blood cell. This reflects the reality in that a red blood cell of someone with type AB also carries both the A and B type of glycoproteins at the same time. Blood type O does not carry either of the two possible glycoproteins, so it's represented by a red blood cell that carries neither the little balls nor the cones. You can thank the Germans for the fact that it's called O. The letter O comes from the German word ohne, meaning without, because red blood cells of people with blood type O carry none of the glycoproteins involved in the ABO blood type system. It may be easiest for you to think of O as 0, the same way we use it in telephone numbers. Because your defensive army can only be allowed to fight the things that are not in your blood, what's present in your plasma depends on what's on your red blood cells. And therefore it depends on your blood type. The top line of the table on this slide shows what antibodies are in the plasma for each blood type. So, type A blood has antibodies against type B antigens in the plasma. The antibodies are called anti-B antibodies because they recognize and react with the little B cone antigens. The anti-B antibodies here are represented by the Y-shaped molecules with the triangular recognition site for the little cones. Type B plasma has anti-A antibodies. These are represented by the Y-shaped molecules with a semicircular recognition site. Type AB plasma contains neither antibody because both antigens are present on the red blood cells, while type O plasma can have both antibodies since neither antigen is present in the red blood cell. Again, if the antibody matching the antigen come together, bad things happen. This is why you can never put the antigen with the matching antibody together inside of a human. But let's see what bad things actually do happen when they meet. Let's imagine somebody who has blood type B, so they have little cones on their red blood cells, and their defensive army consists of anti-A antibodies. This is perfectly safe because anti-A antibodies do not react with B antigens on the red blood cells. But let's say that this person with blood type B and anti-A antibodies was in an accident and lost a lot of blood. Someone who wasn't paying attention gave them a transfusion with type A blood. So type A blood, containing the red blood cells with the little round balls on them, come in, and we'll see what happens next. What happens is that the anti-A antibodies recognize the A antigens on the outside of the red blood cells. The anti-A antibodies are Y-shaped and they can recognize an A antigen with both ends of the Y. Sometimes they'll recognize two antigens on the same red blood cell, but they also can recognize the two antigens on two different red blood cells. What happens then is that the binding of the Y-shaped antibodies causes the blood cells with the A antigen to be linked together, which causes them to build a clump. The binding and the formation of the clump in turn signals the immune system that there is a problem, and it activates additional factors. But just the clump itself is a problem. This is why you can't give somebody with a blood type A transfusion with type B blood. While the clumping reaction is a bad thing when it happens in a body, we can take advantage of it in the lab. And I will talk about that in a second, right after we talk about a slightly different transfusion before we get to that. Let's say, for sake of argument, we have our little friend with blood type B and the anti-A antibodies, and the transfusion is done with a blood type O. What do you think is going to happen this time? What happens is nothing at all, because the A antibodies have nothing at all they can recognize on the type O blood cells. So there's not going to be a reaction, no clumping, no nothing. The agglutination test is based on the fact that your antigens and your antibodies react with each other by clumping. So in this particular test, on the slide, you have one side that's labeled anti-A and one side that's labeled anti-B. And you would put anti-A serum, which contains anti-A antibodies, on the left, and anti-B serum, which contains anti-B antibodies, on the right. If you then add type A blood to that, or an unknown, but in this case it was type A blood, it would then clump with the anti-A antibodies that recognize the A antigen on the red blood cells. It would not clump with the anti-B antibodies that do not recognize the A antigen. So a positive result would be on the left, the clumping of the anti-A antibodies with the A antigen on the red blood cells, whereas the anti-B antibodies do not clump, and therefore that's a negative result. So in this particular case, it would show you that you have an A blood type that you tested. And so let's look back at this compatibility chart. When you're looking at the compatibility chart, the donor blood type, that would be the A blood cell coming in, the red blood cell with the A. And the recipient blood type, that would be where the original blood cells are, you know, your A, your B, your AB, but also your antibodies, the antibodies against the other thing. And so you can imagine that if the donor blood type comes in as an O, they don't have any antigens on their red blood cells. So if the donor blood type comes in as an O, since they don't have any antigens they present, there's nothing that you have to fight. And this is why the O is the universal donor. On the other hand, somebody who is a recipient who has a blood type AB, they present all the major blood types already on their red blood cell. So they're not going to have either antibodies against A or antibodies against B. And this is why somebody with the blood type of AB is the universal recipient. And if you understand this, you should now be able to sit down and just make up this chart without ever having to look it back up. Because you literally just have to think about what is it that's being presented on the red blood cell that's coming in, and what is the defensive army that is available at the recipient that could fight it. So now, without looking at the chart, which one of those blood types is the universal donor, and which one of those blood types is the universal recipient? Can you figure it out? If you said that blood type O is the universal donor because it does not have any antigens that you can fight on the red blood cell, you would be correct. And the blood type AB would be the universal recipient because it does not produce any antibodies against either A or B. It doesn't have any antibodies against either A or B in its plasma. Now that we've hopefully cleared up the ABO blood type, let's talk about the RH system. The RH blood group system is one of those 36 known human blood group systems. It's the second most important after the ABO blood group system. It contains 49 defined group of antigens. The most important ones are D, C, and E. But the only one we really care about is the RHD status. So that's actually what we term positive or negative, depending on what you've got. So your red blood cell can be RHD positive, which means that you wouldn't be making antibodies against it, or it can be RHD negative, which is you would be making antibodies against it. And this is where the problem comes in with the hemolytic disease of the fetus and the newborn. So let's talk about that and talk about what happens there. What you see on this slide is a visual representation of the red blood cells that we've seen before, and I've added the RH factor as a little purple square in there. So, as I said previously, the antibodies then would not be, your plasma would not contain antibodies against what is on your own red blood cells. In somebody who is Rh negative, you would then find the antibodies against the Rh factor. Now this brings me to just make sure that I say this. Obviously your body has antibodies against all kinds of things. You don't just have 3 or 4 different kinds of antibodies. Literally, you have antibodies against whatever is out there, except for the things that are present in your body, because at some point your body eliminates those as possible antibodies during a time in your life when your body is like, oh, this is me and this is other stuff. So, but so the only antibodies we're going to actually list in cases like this are the ones that we care about at this moment in time. And so here we care about the Rh antibody that would be present in somebody who's Rh negative. So let's imagine a mom. She's pregnant with a baby. She's rhesus negative, Rh negative. So her red blood cells do not have the Rh factor on them. So she has a few of those Rh antibodies, but they've never been triggered. So she doesn't really worry about that very much because her body's never seen them before. So she's got a couple of those suckers floating around in her, but they're not, not at great big numbers. And let's say she has a child. And let's say, for sake of argument, the child is AB positive. Most of the time, it won't matter. During the entire pregnancy, it won't matter. But towards the end of the pregnancy, what will happen is that there's a little bit of exchange of blood between the mom and the child. And when that happens, the antibodies in the mom's body recognize there's a foreign invader. And the anti-A antibodies are going to start attacking the blood that just came in. And when they do, they'll clump the red blood cells that got into mom's blood. But by that time, the baby is long gone. The baby has been born, because this happens like within days of birth. So the baby has been born, the baby is safe. A couple of red blood cells in mom's body, they just get destroyed and it's all good. But the other thing that happens is that the antibodies against the Rh factor, where we just had one or two floating around in the body, they now found a target. And anytime an antibody finds a target that it's seen once, it starts creating memory cells that remember. So the trouble actually doesn't start with the first child. The trouble starts with the second child. Because by the time the second child rolls around, mom has lots of antibodies. And the moment that second child's blood shows up in the mom's body, it's immediately attacked. And mom's antibodies will go take over and fight the baby and may actually harm the baby. Now, how do we treat this? The way we treat this is by injecting mothers who have blood type B, rhesus negative, who potentially have children who are Rh positive. We inject them with antibodies against the Rh factor. By doing so, it binds up the blood without mom actually creating the factor herself, without her creating the antibodies. And when she doesn't create the antibodies, she doesn't create the memory cells. So the next time another Rh positive baby comes around, it'll be the same as if she'd never seen the Rh factor before. with the blood transfusion, your development of antibodies for the Rh factor is the same, though, as with the development for the ABO blood system. So if you're Rh positive, you don't have any antibodies against the Rh factor. If you're Rh negative, you do. Given all that information, you should now be able to figure out who's gonna die. Ready for the solution? Who is going to die? A positive blood can only be transfused into people who are Rh positive, because Rh negative people will have antibodies against the Rh factor. It can also go only into people who contain the A from the ABO blood group, which means that it can only go into people that have A positive blood or AB positive blood. Did you get it right?